to with Mr. Adams. How to with Mr. Adams. How to with... Hi, and welcome to another episode of How To with Mr. Adams. Today we are going to be talking about how to determine the surface area of complex shapes. Our first example is going to be looking at a triangular prism. So we're going to find the area of this triangular prism. So if you remember from previous classes, we have talked about how to find the area of a triangle, and you've learned before how to find the area of a rectangle. So we're just going to do that, break this one down, and find out the area of this entire shape. So the first thing I'm going to do, I'm going to label all my sides here. So I can see I have a side length of this triangle is 5 centimeters, its base is 6 centimeters, and the length of the rectangular part of this prism is 8 centimeters. So let's start with labeling the different parts of my triangle. So I know that I have two parts that are triangular. So I'm going to call this A. We'll call it A1. I'm going to call this side here A2. And now I also have a bottom triangle that you can't, or a bottom rectangle that you can't see. So I'm just going to show you what it looks like here with using this dotted line. So if I could see right through the shape, I would also see that there's a bottom section here. So I'm going to call that one down there A3. All right, so first thing I'm going to do is determine what my A1 is. Now this is going to be your most complicated shape that you need to find the area of. If you remember from the previous class that we learned that you need to have your base and your height in order to find the area of a triangle. And the most important thing to remember was base and height always form a 90-degree angle with each other. So as you can see here, if this is my base, I don't have a 90-degree angle with this side length of the triangle. So I need to bisect the base. And to do that, I'm going to use a straight edge. I'm going to bisect the base, but I don't like doing everything up here. I'm going to redraw the picture down here. So let's just redraw that triangle right here really quick. Here's my triangle. I know that my side is an isosceles triangle. This is 5 centimeters, this is 5 centimeters, this is 6 centimeters. Okay, and I'll just put an arrow here instead of an equal sign. So I have 5 centimeters, 5 centimeters, and 6 centimeters. I'm going to bisect the base. So I'm going to take my straight edge. In this case, I'm just using a piece of paper. I'm going to draw a line straight down. And when I bisect my base in an isosceles triangle at the vertex, this is the vertex where the equal sides meet, so 5 centimeters and 5 centimeters, where they meet, when I draw a line straight down, this will bisect my base. So now I have two smaller triangles. So let's determine now what is my height. Okay, if you recall, in order to find my height, I can use Pythagorean's theorem. I know two of the sides. If this entire length here is 6, I know half of it is going to be 3, so I'm just going to use a different color here. So I know two of my sides of this triangle, and I'm missing a third. So I'm going to use Pythagorean's theorem. So if you remember, that was a squared plus b squared equals c squared. Notice how I'm labeling all of what I'm doing, writing down my formulas before I start actually using them. So I'm going to use Pythagorean's theorem. Now the tricky part is remembering what is c. And you guys did a good job of reminding me that c is the side that is opposite of your 90-degree angle. So here's my 90-degree angle. Whatever is opposite of that is my c. So I'm going to make my substitution. My c is 5. I'm going to put it in brackets and square everything that's inside the brackets. Now my a and my b, it doesn't really matter which I pick. I know that this is A and this is B, or vice versa. It doesn't matter. So I'm going to call A will be my 3, and B will be my unknown side. Because remember, in order to find the area of a triangle, you need your base and your height. That's why we are doing this. So A is 3. I'm just substituting into this formula, plus B squared. Now I just multiply things out. 3 squared, that means 3 times 3. 3 times 3. 5 squared means 5 times 5. So this will give me 9, plus B squared hasn't changed, equals 25. All right, so now I just need to isolate my variable. And we've done this a few times in class now. You want to get B all by itself. First thing we're going to do is get rid of this 9. We'll get rid of any addition or subtraction parts to that equation. So I'm going to, in order to get rid of 9, I need to do the opposite of the operation. This is a positive 9. If there's no sign on it, you know it's a positive. So I'm going to subtract 9 from both sides. And I'm going to subtract 9 from this side. You don't have to put this line here. Okay, so 9 minus 9 is 0. Those cancel each other out. 25 minus 9 is 16. So I end up with B squared equals 16. Remember, we're okay, good. Yeah, B squared equals 16. Okay, now we need to get B all by itself. I want to know what B is all on its lonesome. So in order to do that, we need to isolate the variable and do the opposite operation of what is happening to B. So the operation that's happening to B right now is we have B squared. The opposite of squaring something is taking the square root. So I'm going to take the square root of both sides. The square root of B squared is B. The square root of 16 is 4. So I know that my missing side on this triangle here is 4 centimeters. That was the most difficult part of this problem. Now I can solve the area of A1, A2, and A3, which I'm going to do right over here. So let's do A1. A1 is a triangle, so we need to use the formula base times height divided by 2. Okay, so my A1, my base, I know for the entire triangle, my base is 6. It's not 3. 3 is the base of this half of the triangle, but I want to use the entire base of my triangle. So my base is 6. My height, which we just found out, is 4 centimeters. And we're going to divide that all by 2. Okay, so my A1 is going to equal 24. 6 times 4 is 24. And then I'll divide that by 2. Slide this up a little bit. So my A1 equals 12 centimeters squared. Make sure you have your units. Remember, that's just part of what we're doing. That just gives me the triangle. But wait a second, how many triangles are there? There's one in the front, and there's one over here in the back. So I need to make sure I take that 12 centimeters squared. And since there's 2 triangles that are equal size, I'm going to multiply that by 2. So my A1 will equal 24 centimeters squared. All my A1s. Okay, so this is the important information that I got from this one. Good. Let's do A2 next. I'm going to put it right over here. I'm going to redraw A2 first. A2 is a rectangle right here. I know one side length is 8 centimeters. And the other side length is, well, this is equal to this side, which is 5 centimeters. So if you remember, the area of a rectangle is length times width. So I'm going to get 8 times 5, which equals 40 centimeters squared. But again, there are 2 of these. So I need to multiply my final answer by 2. Okay, through the magic of television, I've done some of this work ahead of time. We last left off right here where the area of 2 was 40 centimeters squared, and there's 2 of them, so I need to multiply it by 2. So 40 centimeters times 2 gives me the area of all my A2s, which would be 80 centimeters squared. Next thing we need to do is find the area of A3. So A3 is right up here. I can see it's on the bottom. And the dimensions of this one are 8 centimeters by 6 centimeters. So I'm going to just redraw it right here. A3 is 6 centimeters by 8 centimeters. So remember, area is length times width, which in this case would be 8 times 6, 8 centimeters times 6. 8 times 6 is 48. So that gives me my area of the bottom of the triangular prism. Now remember, we have to figure out how many of those are there. Are there 2 A3s, like there was 2 A1s, and there was 2 A2s? Is there 2 A3s? Well, if we look at the picture, the A3s are just the bottom of this prism, and there is only 1. So we don't need to multiply this one by 2. So I'm going to underline that A3. So I have all my A1s is 24 centimeters squared, all my A2s are 80 centimeters squared, all my A3s are 48 centimeters squared. So in order to find the area of this prism, I need to add them all up. 24 plus 80 plus 48, which gives me a total of 152 centimeters squared. And to finish this off, I'm going to write a statement. Therefore, the area of this triangular prism is 152 centimeters squared. And that is how you find the area of a triangular prism.